So thank you very much to the organizers for putting together this conference. It's an honor to be presenting here. The paper that I will present today is very much in line with Emmanuel's recent work on input-output networks and macros. So there is a lot of his influence in this paper. And let me also say that he really shaped the way that I think more broadly about economics problems. And I also feel very grateful to Emmanuel as a mentor. And I think many of his students will agree that he didn't tell us what to do, but he helped us remove the obstacles that prevented us from creating what we wanted to create. So I do my best to keep his teaching alive in my work. All right, so this paper is entitled Monetary Non-Neutrality in the Cross-section. Sorry. Okay. All right, so why do we need to think about monetary policy in the cross-section? Well, traditionally, monetary policy has been conceived of as an instrument that is neutral for redistribution purposes, and it is meant to fix aggregate variables. So the literature has focused on understanding the aggregate effects of monetary policy, and only recently there is some new theory and evidence on the cross-sectional effects of monetary policy. So in this paper, I take a particular stance on what kind of cross-sectional effects I want to study. And in particular, I will consider how policy affects different worker groups. And by this, I mean people potentially in different occupations or different regions or different demographics. So as you will see, the model per se is neutral, so it's silent on how exactly you take to the data the different worker groups. But then in the particular calibration that I focus on, I'm going to look to consider groups as being people in different occupations. And in particular, I will focus on the heterogeneous effect of monetary policy on these worker groups through their interaction with the production side. That is going to shape their real income process. So this is a pretty different stance from the traditional way to think about heterogeneous effects of monetary policy, which is instead acting through the consumer-Euler equation. So the Henk models are the main models in this literature, and there all the action comes from different borrowing constraints and different marginal propensities to consume. So in this paper, I'm going to shut down this channel, and I'm going to entirely focus on the production side. So here is a pretty ugly picture that illustrates the kind of economy that I have in mind. You will know that the paper is ready to be published when I will come up with a better picture. But anyways, so in the middle you can see there is, in the middle you can see there is the production sector, and all the industries are the purple dots. And on the outside you can see the different worker types, that's the yellow little men. And they interact with the production side in two ways. First, they are employed by potentially different industries, and second, they consume different types of goods. So essentially, I will argue that both channels are importantly shape heterogeneity in their income process. And I will focus on, let's say, the traditional the traditional channel through which monetary policy acts, which is price stickiness. So essentially, these workers will be employed by sectors with different price rigidity, and they will consume bundles that have different price stickiness. All right. So to understand why this matters for the effect of monetary policy, let me start by reviewing the representative agent benchmark. And then we will see how the intuitions from this benchmark actually can carry over to the cross-section. So just to fix ideas, one way to think of monetary policy is that somehow the central bank has the ability to pin down the aggregate nominal expenditure. All right, and the way I represent this is through this cash in advance constraint. So this is telling us that nominal expenditure, which is price times output, is equal to the change in money supply. All right. So this equation already highlights that there is a sort of a trade-off between increasing prices and increasing output for a given money supply. And this trade-off is captured in the New Keynesian framework by the Phillips curve. Essentially, the slope kappa of the Phillips curve tells us by how much prices increase for a 1% increase in the output gap. All right. So we see from combining these two equations, we see that whenever the Phillips curve is flatter, monetary policy can stimulate demand a lot without prices increasing too much. All right. So we say that there is more monetary non-neutrality because monetary policy has larger real effects. Okay. And more in general, there is going to be this negative correlation between the effect of monetary policy on output and the effect of monetary policy on prices. Okay, the next question is what determines the slope of the Phillips curve? And in traditional New Keynesian models, there's going to be two elements. One is the degree of price rigidity, and the other is the elasticity of labor supply. Here, basically, the degree. Here, I will allow for heterogeneity across agents in both of these elements, but for simplicity, I will mostly focus on price stickiness. All right, so that was the representative agent benchmark, and let's see how this intuition can carry through to the cross-sectional effects of monetary policy. So before I showed you the ugly picture with the big network, but to give intuition, I will actually strip it down to the simplest possible economy. So again, to make it more fun, this is going to be Italy versus Germany economy. So we're going to have the Italian worker who doesn't like wage cuts, so they will have very sticky wages, and the German worker who is like okay with keep working at a low wage. All right, and then we have the Italian worker and the German worker happily cooperate to make one consumption good, which is purchased by the households. And I will assume for simplicity they have equal share. Okay, and then we have the ECB who has to engineer a contraction. All right, so the question is what happens to the relative employment of these two workers? So now there is a contraction, so essentially wages should fall. But the problem is the Italian wage is not going to fall. So essentially the relative wage of the Italian guy is going to increase. So Italian firms are going to be less competitive, and people will substitute away from Italian good and towards German good. And so that's why the relative employment of the German people will increase compared to the Italian workers. Okay, so again, we see that we have a negative correlation between the quantity effect, so the employment effect, and the price effect, which in this case is the two workers' wages. All right. And this intuition will keep holding also when we add the general network, but then we will not just have a correlation between employment and wages. We will need to define sector by agent Phillips curve and combine them in the correct way to study the cross-sectional effects. All right. So that's why we need the bigger model. Okay. So as an important note, these cross-sectional effects also have some aggregate implications, because to the extent that the economy has the ability to substitute towards the flat Phillips curve agents, then this increases, essentially this dampens the overall inflation response and increases monetary non-neutrality. But quantitatively, this effect is going to turn out to be small. So I will mostly focus on the cross-sectional effects. So this is a good time to ask questions, and by the way, questions are very much encouraged, so feel free to stop me anytime. All right. This is just this was a preview of the main theoretical mechanism. I also have a somewhat preliminary calibration where I take the model to the US data, and I look at the cross-sectional effects of monetary policy on workers in different occupations. And I find that even just from accounting for different price stickiness across sectors, the impact response of employment to a 1% money growth shock is very heterogeneous across people, it ranges from 0.25% to 1.1% across occupations. And I find that a lot of the heterogeneity is actually driven by heterogeneity in price stickiness across industries, and not as much from direct heterogeneity in wage rigidities. And again, the aggregate effects are actually instead quite small.
Sorry, when you talk about heterogeneity in price stickiness, you're talking about price stickiness or wage stickiness? Or?
So I have both in the model, but it turns out that the price are going to matter more.
The price matters more.
Yeah, and the presence of the network. I will show the quantitative results at the end. Okay. Great, so I will mostly skip the literature, but just to give you a sense of I guess maybe many of you wonder, like we have seen a lot of recent models of monetary policy with input-output, what's different in this model. And the main difference here is that I abandoned the representative agent hypothesis, which is common to most of the recent models, and I precisely focus on heterogeneous agents and cross-sectional effects. All right, so here is a roadmap. First, I will present some stylized facts just to document heterogeneity in the dimension that I mentioned before. And then I will go through the theory, give you some examples, and then present the calibration. So the empirical parts are somewhat more preliminary, so any feedback is very welcome. Great, so stylized facts. So first of all, this histogram plots the distribution of the average price stickiness of the sectors where different occupations are hired. So here I'm taking a classification of 22 occupations for the US, and I am constructing a measure of the probability that each occupation end up in each sector. And then I average the price adjustment probabilities of the sectors where each occupation is employed using these probabilities. All right. So the message of the graph is that there is a fair amount of dispersion in the price rigidity faced by different occupations via the employment channel. As I mentioned before, there is also a consumption channel, so different occupations might buy more or less sticky price baskets. As it turns out, the heterogeneity here is not very big, so here is the histogram. You can see the dispersion is much smaller. All right, so the next pictures are meant to connect the micro data that I gave you before that are based on direct measures of price adjustment probability with some macro moments, let's call them macro moments, that are connected with what we usually think of business cycle facts. And one important fact is the standard deviation of prices and employment. So here you can see a measure of the dispersion of the standard deviation of inflation in the hiring industries, and we see that this is also quite large, and importantly goes together very well with the micro estimate of price adjustment frequency. All right, so as the example suggested, we don't just care about prices, but we also care about wages. So here I do kind of the same. I measure the same standard deviation, but instead for hourly wages at the occupation level. And we see that, again, there is a fair amount of dispersion. And interesting enough, this is very negatively correlated with the standard deviation of employment shares at the occupation levels. So if you recall from our Italy versus Germany example, that was precisely a prediction of the model that there should be a negative covariance between the employment response and the wage response. And I find the same negative correlation also when I look, instead of the standard deviation, I look at another important business cycle moment, which is the correlation of the occupation level employment shares with aggregate employment share, and the correlation of the hourly wage with the aggregate employment share. So essentially, this is saying whenever employment for an occupation is more cyclical, then the wage of this occupation is going to be less cyclical. All right.
So just when you say standard deviation on the previous graphs, the y-axis, that's standard deviation across?
It's a time series standard deviation. All right, so these are the stylized facts. Let me move on. If there are no questions, let me move on to the theory. All right, so to represent the network that I showed you in the picture, I'm going to have in my environment a set of H worker types and production sectors. So H are the little orange workers, and N are going to be the purple dots. Here are several elements of heterogeneity, and I will point to you which ones are most important along the way. So agents are going to consume different bundles of goods, and they are going to own different shares of the sectors and the fixed factors, and they are also going to face different wage rigidity and labor supply elasticity. Sectors hire different bundles of workers, fixed factors in, oh, actually I don't have fixed factors, so forget. Workers in intermediate inputs, and they have price rigidity and different price rigidity and different demand elasticity. All right. So the dimensions of heterogeneity that are going to be fundamental eventually are going to be the different wage rigidity, labor supply elasticity, and the different price rigidity across sectors. And I will show you that without these elements of heterogeneity, you basically get little or no cross-sectional effects. But once you have these elements of heterogeneity, then they are going to interact with the others, and potentially this is going to amplify the cross-sectional effects. All right. So throughout the analysis, I will study a log linearized model. And the beauty of this kind of models is that the parameters that govern the log linearized economy can be actually calibrated from national accounts, and that's what I do when I take the model to the data. All right, so here is the consumption side of the model. Essentially, this replicates the baseline New Keynesian framework, but it just allows from agent-specific preferences. So on the consumption side, agents consume a bundle of all the goods produced in the economy, and the bundle can be type-specific. So different agents have different consumption shares. Besides consumption utility, agents also dislike labor, and their labor supply elasticity and wealth effect are going to be also agent-specific. Here is the budget constraint. So consumption is going to equal labor income, profit income, and potentially borrowing. And we also have laws of motions for assets. For today's presentation, I'm actually going to assume I'm going to work with a financial autarky model, so we can forget about this part, but the same intuitions carry through to the general model. All right, so here is just some notation, so you'll have to be a bit patient with me. That summarizes essentially the consumption side of the model. So big gamma and big phi collect all the agents' wealth effects and inverse Frisch elasticities. And then importantly, the beta is going to denote the agent's consumption baskets. So this is going to be a matrix that has elements IH denoting consumption share of agent H in good I. And then an important object when we talk about aggregation is going to be the agent's income shares. So these are going to be the agent consumption in total GDP, essentially. And so whenever I want to talk about aggregate variables, I'm going to mean the share-weighted agent-level variables. So aggregate real GDP is going to be, changes in aggregate real GDP are going to be changes in the share-weighted consumption, and changes in the GDP deflator are going to be share-weighted changes in consumer prices. Okay. Great. So production side of the model is a standard production network where there are many sectors that have constant returns to scale, and production function takes as input labor of all the agents and intermediate inputs. All right. So there's not going to be a one-to-one mapping between agents and sectors, but different sectors will use different types of labor with different intensity. Okay. And then within each sector, I use the standard New Keynesian modeling. So we'll have a continuum of firms that, and there will be a fraction, there will be Calvo pricing, so only a fraction delta I of the firms can adjust their price after they see the realization of monetary policy. Right, so someone before asked about sticky wages. In this framework, it's actually very easy to model sticky wages just by adding a fictitious sector that I call a labor union, and this sector will have sticky prices. And so that's the price of the union is what I'm going to call the sticky wage. Yes?
So there's many types of labor, right?
That's right.
And the firm I is hiring all of the types?
Yes, yes, this is bad notation, but I should put a bracket. Yeah.
It's like it had a curly.
Yes, there is a missing curly bracket. Yes, it's hiring all of the type, but the heterogeneity is going to come from the fact that different industries hire different types with different intensity. So, for example, university hire a lot of PhD graduates, but maybe like cleaning company doesn't. And so, yeah, okay. Great. And so there is going to, just a technicality, I'm going to study an efficient equilibrium, so I will have appropriate input subsidies as usual. All right. So just one more notation slide, and then we're done, and we can go to more fun results. So the price rigidity, I will collect them into a big matrix delta that denotes, it's a diagonal matrix that denotes the sectoral price rigidity. And then the parameters of the input-output network are going to be summarized by the labor shares and the input-output matrix. So the input-output matrix, okay, so sorry, there is another typo. This should just be alpha IH. And so, sorry, these are the labor shares, should be alpha IH. So these represent the share of H labor in sector I. And the input-output matrix is standard. Omega ij is the share of good J in sector I's cost. All right. So once we have this object, we can start playing around and understand how the network shapes the effect of shocks, the transmission of shocks. So essentially, the Leontief inverse is the key object that tells us the connection between two sectors I and J, not just directly, which is the omega ij, but also indirectly through intermediate inputs. And specifically, these matrices account for paths of any length between I and J. So it is a geometric sum, where the first element is a direct effect, the second is through path of length 2, and so on. All right? So using this Leontief inverse, we can construct the agent's Domer weights, which tell us the direct and indirect content of each good in each agent consumption. So for example, I do not consume any oil directly, but I do consume a lot of goods that are produced using oil. So my beta oil is going to be 0 because I have 0 consumption, but my lambda oil is going to be positive. All right. And in a similar way, we can also determine what's the total content of each agent labor in each other agent consumption. And that's given by the product of the labor shares with the Domer weights. All right. So these are just basic definitions, but they're going to reappear a lot throughout the network. So, thank you for bearing with me. All right. So here is a bit of a technical note, but in equilibrium, we can actually connect these input-output weights with the agent's shares. And in particular, each agent's income share is going to be a weighted average of his labor content in all the other agents' consumption. And this is kind of an important property because it allows us to define when a network is connected and we have a unique equilibrium. All right. Great. So now let's conclude by looking at the policy instruments. So today I'm going to focus on a model where the central bank is setting the money supply. So I assume that agents are in financial autarky, and so they cannot borrow and lend, the aggregate nominal expenditure is going to be constrained to be equal to the money supply. Okay. The intuitions carry through to a model where the central bank is setting the nominal interest rate, which is a more traditional model, but for simplicity of exposition, I'm going to present the cash in advance model today. All right, so now we're ready for the main results. So basically, the big model can be boiled down to 3 equations. The one equation is simple; it's the aggregate demand equation that is given by the cash in advance constraint. Then the second equation, like the representative agent economy that I showed you before, is going to be given by the Phillips curve that captures the supply block. But now this Phillips curve is going to be a bit more complicated compared to the representative agent model, because now we have many sectors and many agents. So there are going to be sector by agent slopes of the Phillips curve. And these slopes will be key in shaping the cross-sectional effects of monetary policy. And my next step will be to show you how these slopes depend on the primitives of the production network. And finally, we will have a third equation, which is the cross-sectional demand for different workers. All right. And I will also show you how this can be derived in terms of the primitives. So let me start by giving some intuition for these sector by agent Phillips curves. So here, what's the intuition behind the Phillips curve slope? Well, essentially, the Phillips curve slope captured the effect of increasing employment on prices. So if we increase labor demand, this means that we need to convince workers to work more, so we need to pay them a higher wage. So this raises marginal costs and increases prices. Okay? So the slope of the Phillips curve captures this chain. So it has 3 pieces that essentially will capture heterogeneity in the price rigidity faced by different workers in production and in consumption. And they will also capture heterogeneity in the labor supply elasticity. So the labor supply elasticity piece is this phi at the end. The price rigidity in production essentially captures how a change in the nominal wage is transmitted into prices through the network. So alpha is going to be the labor share. That is the direct effect of wages and marginal cost. Then there is going to be this Leontief inverse adjusted by price rigidity that is going to tell us how this change in wages propagates through the network. And finally, marginal costs are converted into prices through the price stickiness Calvo parameter. And then we're going to have a further term that captures the effect of price rigidity in consumption. And essentially, this goes through a general equilibrium effect, whereby if I increase wages, prices are also going to respond. So real wages will go up by less than 1-to-1 with nominal wages. And these terms capture precisely the fact that some workers might be exposed to goods with flexible price, so they will have a smaller increase in real wage per unit of increase in nominal wage, and vice versa. Other people consume sticky goods, and so they will have a bigger increase in real wage. All right. So, but this expression is important because it's really isolating the effect of price rigidity through the production and the consumption channel. And we will see next that the production channel is actually going to be more important. All right, so the second piece, the second new piece of the heterogeneous agents model was the law of motion for cross-sectional employment. And this can actually be described in a streamlined way through this cross-sectional multiplier that I call M. So before I show you a bit what goes into the expression for M, let me tell you what's the intuition here behind it. So essentially, a monetary expansion, we can think of it as the central bank dropping some more money, 1% more income in the pockets of all agents. All right. So essentially, if everyone is 1% richer, and before they were optimizing their consumption, then expenditure is going to increase proportionally for all goods. And so that's what the big one represents here. However, like even a proportional increase in the labor demand for different agents is going to have a heterogeneous effect on the agent's real wages. And that's because agents potentially have different labor supply elasticities, but also because they might have different wage rigidities. All right, so in the example before, if the wage for the Italian worker is going to go up by less than the wage of the German worker, right? And so this is going to feed back into a change in the relative price of different goods. And in turn, this is going to affect the relative demand for different goods, and so the relative demand for the labor of the people who makes this good. All right. And so this is what captured by the matrix M that is going to capture a further adjustment in the labor demand and a further adjustment in wages and so on. All right. So as I kind of explained in words, heterogeneity is going to matter through 2 channels. The first is changes in relative prices that are going to trigger expenditure switching. And the second channel is going to be a reallocation of income across agents. All right, so for time constraint, I'll go a bit fast over these big formulas, but essentially the first piece of this multiplier is going to tell us that labor demand for some agent H is going to drop if the price of the goods where that employ a lot of H labor goes up. All right, and of course this is particularly true if H has a flexible wage. All right, and the effect is going to be even larger if the product of H is substitutable, is good substitute with other goods in the economy. All right. The reallocation of income effect, an important implication of the model is that this is actually going to matter only to the extent that consumers have different consumption baskets. So this is kind of intuitive. I have equal MPC here. So reallocation of income is only going to matter if essentially different people consume different goods, and so if some type become richer, then the workers who produce their consumption goods are also going to benefit in terms of employment. All right, great. So let's see this mechanism at work in our workers example of Italy versus Germany. So just to recall, Italian worker had a flat Phillips curve and like sticky wage, and German worker had flexible wage. So we see that the Italian worker Phillips curve, so the effect of increasing Italian employment on good prices, is going to be proportional to its wage stickiness, which is smaller than the German wage stickiness. So the Italian worker is going to be a flat Phillips curve worker. And when we look at the cross-sectional effect of a monetary expansion on the two workers' employment, we see that essentially the employment is going to go up by more for the sticky workers, and that's going to be proportional to the difference in the wage rigidity of the two workers, but it's also proportional to the substitution elasticity between the two workers. And that's really telling us that if workers are complements, it doesn't matter what the relative price is. Firms are not going to substitute, but if they're good, if they're very substitutable, then there's going to be a large cross-sectional employment effect. Interestingly, employment is not a sufficient statistic for consumption. Of course, income depends on the product of employment and wages. So the comparative static for consumption is not that clean, but relative consumption will increase for the sticky workers only if the two are substitute. If the two are complements, actually the flex worker is going to benefit in terms of consumption. So this tells us also that the welfare implications are not obvious. All right. How does, can we not just do away with input-output linkages and use the intuition for the simple model? Well, this framework is going to help us to discipline how input-output linkages shape the degree of nominal rigidities faced by different workers. And in particular, here I have a simple example where I have an intermediate good producer and a final good producer. I don't have time to go through in detail, but essentially the key intuition is that the intermediate good producer is going to face price rigidity twice, because his product is sticky and the final good is sticky, whereas the final good producer only faces price stickiness in the final stage. So essentially the cross-sectional effect follows the same formula as before, but just replacing the wage rigidity parameters with appropriate combination of the price rigidity parameters in the two sectors. All right. But so this tells us precisely that when we have the input-output network, essentially upstream good producers are going to be the ones that face that are like the sticky price people. All right. So and this slide just shows that the labor supply elasticity has pretty much the same intuition. So an expansion is going to benefit elastic workers because their relative wage will fall. Great. So I have quite little time, I guess, to go through aggregate non-neutrality and calibration, but let me just show you very quickly the key result for aggregate monetary non-neutrality. So starting from the representative benchmark, this formula tells us what happens to employment when money supply goes up by 1%. And we see that this is inversely proportional to the slope of the Phillips curve. Once we have heterogeneous agents, we actually get a very similar formula. But now this is going to depend on a notion, a prepared notion of the slope of the aggregate Phillips curve, but also on the covariance between the employment response of different workers and the sensitivity of consumer prices to the different employment, to the workers' employment, all right? So essentially the idea is that if employment goes up more for agents with flat Phillips curves, then there is more monetary non-neutrality in the economy, all right? And that's what happened in the examples that I showed you before. So I haven't proved the theorem that says that this is always true, but I also haven't found a counterexample, so I'm still trying. But I think that, but essentially the intuition here is that the economy can substitute towards flat Phillips curve workers, and so this increases the aggregate non-neutrality.
Can I ask you a quick question about
Yes.
that? So as far as I understand, that employment effect is endogenous due to the substitution.
Yes. Yes, that's what the formula, the big M, showed you.
But you could imagine if someone wanting to make a policy could help that along if you wanted. I mean, you could, if you had other instruments, you could steer it.
Yes.
Have you thought about that?
Yes, that's right. So I have not thought exactly about that, but I have thought about the question, can we actually eliminate cross-sectional effects of monetary policy? So it's kind of similar, like it's trying to stir different, like employment effects. And actually the way that you do it, it's actually a bit of a complicated policy because you actually subsidize sectors proportionately to their exposure to wages. So you say, assume that we increase the employment uniformly for everyone. How would that affect costs in different sectors? And let's subsidize the sectors basically subsidize the sectors whose costs will increase more. So if you do that, essentially you eliminate any cross-sectional effect of monetary policy. Right, cool. And you replicate the representative agent economy. But the important note is that you can do it only if you have heterogeneity in price rigidity and nothing else. If you also have heterogeneity in labor supply elasticity or in an extension where you have fixed factors, then this doesn't work anymore. Okay. Great, so let me just show you a few pictures from the calibration. This is showing impulse responses to a 1% monetary shock in different occupations. And the blue lines are the occupation response, the red line is the aggregate. I'm sorry, this is not very visible here. But anyway, the bottom line is that the discrepancy between occupation specific and aggregate is pretty large for many occupations. And this is another important picture. This is just showing the impact response by occupation to a 1% monetary shock. And the left axis and the blue line are relative to the baseline model, and the right axis for you and the red line are corresponding to a model without input-output linkages. So I'm still allowing for heterogeneity in wage rigidity and in price rigidity, but I am killing the input-output linkages. And you see that reading from the right axis, there is much less non-neutrality in the model without input-output linkages, and that we knew already from the representative agent models, like my journal paper. But the other message is that the cross-sectional non-neutrality is also compressed in the model without input-output linkages. And then a final message is that, so these horizontal dash and dotted lines capture aggregate non-neutrality. The dash line is in the real model. The dotted line is the one that we compute naively, ignoring heterogeneity, and we see that they are very similar. All right, so I guess I'm about out of time, so let me skip to the conclusion. In this paper, I show that monetary policy has important cross-sectional effects through whereby basically different agency income depends on how they interact with the production side. So in the cross-section, I show that employment increases by more for what I characterize as flat Phillips curve workers. And in the aggregate, the ability of the economy to substitute towards these workers increase monetary non-neutrality. Quantitatively, I find that the cross-sectional effect is significant, and that it is mainly driven by the input-output structure. So I didn't show you the result today, but wage rigidity seems to matter much less than price rigidity where you are employed. And just a little advertisement, this same framework can be used to address a lot of other questions, and I'm working on these. So it can speak to the effect of targeted government spending to different sectors, and it can also discipline the way that we think about cross-sectional Phillips curve estimation and, of course, open economy issues. All right, thank you very much.